Hello, welcome to Engineering Computations tutorial week 4. I'll be discussing the first question of the tutorial sheet. The solution to this exercise is available in UTS Online, and I would encourage all students to try this exercise on your own. All right, so let's get started. What we have here is the solutions or a sample solution to the first problem. I will start a new worksheet. So I'll be showing you how to design this spreadsheet or this sheet from scratch. This will be a new worksheet and I'll start working here. Okay, the purpose of this first exercise is to look at a few simple equations. We are trying to locate the roots of those equations, and we'll be using two very simple techniques. We'll be using simple guessing techniques. We'll be using simple guesses, and we'll be also be using an improved guessing and checking technique. So let's get started with simple guesses. Our initial first equation that we're trying to solve is f of x equals x to the power of 3 minus 18x plus 13 equals 0. When we are presented with an equation like this, it's always a good idea to plot it first. So this helps us visualize where the roots can possibly lie on a curve before we use an iterative technique in order to locate them. So in order to create a very simple plot to visually locate these roots, I will create this simple table. The first column will represent x, which is the horizontal axis, and the next column represents f of x, which would be the vertical axis. So I'll create a range of values for the horizontal axis, starting with -1, and this would be -0.9. We can use the autofill feature to automatically fill the numbers here from -1 all the way to 1. So all you need to do is to just drag the handle in the bottom right corner. And we'll now write a formula to calculate f of x. This will be x to the power of 3 minus 18 times x plus 13. I would now copy and paste this cell into the cells below here by dragging the handle all the way to the bottom. And now we should be able to create a simple plot to help us locate the roots. So this would be a scatter plot without the points. This is also known as a scatter with smooth lines. And this plot is very useful. It tells us that there is a root that is lying between 0.5 and 1. These roots are where the curve is intersecting the horizontal axis. So it's very clear from this plot that we have one root that we need to locate. Once we have located where that root is, or where that root can possibly lie, we can use this to perform our guesses. So I'll just remove a few values here. In order to use simple guesses, you'll just need to guess the value of x. And let's try 0.7 and see if f of x is close to 0. This does not seem to be a very good result, as the value of f of x is pretty high. So I will drag this cell to the next couple of cells below here to increase the number of guesses, and I'll just make guesses. So let's try 0.8. Okay, that's not too good. I'll try 0.75, and we can see that the results have improved. F of x is much closer to 0 now. Let's try 0.74. Let's try 0.745. Let's try 0.7452, and so on. Now this will be our final result. And I'll stop iterating here because the value of f of x is close enough to 0. Let me highlight this and make this cell bold so it's clear to all of us that this is our final result. Okay, great. That's our first simple guesses. This test is a little crude and it will take many iterations before you reach a good guess value. So what we can do to improve on this iterative technique is to use the improved guess and check iteration. To do this, we will need to rewrite our original equation here into this new form. The new form would be x of c equals f of xg. So what we need to do is we'll need to take this formula and rearrange the terms here using simple algebra to get this form. And once our equation is in this form, we'll be able to use the improved guessing and checking technique. So let's rearrange the terms. Okay, now in order to rearrange the terms, I'll add both sides of the equation with 18x. And then I will divide both sides of the equation by 18. And I'll swap both sides of the equation. And I'll then replace the x on the left-hand side with xc, and I'll replace the x on the right-hand side with xg. So this would be xc equals xg to the power of 3 plus 13 divided by 18. Once we've done that, we can now continue with our improved guessing and checking technique. Before I build a spreadsheet to solve this problem, I will introduce the concept of tolerance. So tolerance is a predefined limit or a predefined number. We will continue iterating if our error is larger than a predefined tolerance of, let's say, 0.0001. And let me just reduce the number of zeros here. And we will stop iterating if the error is smaller than this tolerance. Okay, so let's create a table containing 4 columns. And this will be our test. Now, xg will be our initial guess. So say, let me put the value of 1. xc will be a function of xg, and it's given in cell A16, which we determined earlier. This will be A20 to the power of 3 plus 13, and I'll just put a bunch of brackets here and divide this entire expression by 18. All right, now the error will be the difference between xg and xc. So this will be cell A20 minus cell B20. We are only interested in the magnitude of this error. So I will add the ABS function here. The ABS function returns the absolute value of a number, and it returns a number without its sign. And finally, we will put a test. We will keep iterating if our error is larger than our predefined tolerance. In this case, our predefined tolerance is 0.001. We'll use a simple if statement to compare those two values. So if the error is larger then our predefined tolerance, also known as epsilon, we will keep iterating. And if the condition is not true, we'll assume that the results are close enough, meaning that convergence has been met, and I'll press enter. We're nearly done. The guesses of x for our subsequent iterations will be the previous iteration's computed value. So in other words, this cell will equal to xc of the previous row. Now, I think all formulas are now complete, and I should be able to drag all three cells to the next row. And let's see this. Okay, now there is an error here because this thing is telling us that we should stop iterating in the second row, which is not what we expect. The error is still pretty large, which is very close to 0.03, and that's clearly larger than the tolerance. So something is wrong here. Now, the reason why there's a mistake in the spreadsheet is because I have not fixed B18 as a fixed or an absolute reference. If I were to press, press F2 to examine, it should be on this cell. If I were to examine the formula in this cell, I am comparing the error, which is the cell C21, against B19, which is obviously incorrect, as there's no number in cell B19. So in order to fix this, I'll press F2 and I'll press F4 into this cell, which would make a B18 a fixed reference. And now if I were to paste this here, it should now be correct. So we'll stop iterating in the fifth row, and I'll highlight these cells and I will make this number bold. So it's clear to the reader, it's clear to you and me that this is our final result. So this is a pretty good way to calculate the root of an equation when no solution can be easily found. Now let's try this again with the second question, or the second part of the first question. We'll use the simple guessing technique first. And for the second question, we are solving f of x equals cos x minus 0.2. So let's create a simple table to perform our simple guesses. This would be x, and this would be f of x. Our initial guess, let's start with 1, and f of x will be cos 1. And this is cos 1 radian, not 1 degree, minus 1 minus 0.2. I now copy and paste this row of these two cells to the next couple of rows, and I should be able to use this to perform a couple of guesses. So let me try this with 0.6, 0.61, 0.616124. And the value of fx is very close to the value of 0. So this indicates that this value, this long number, is a pretty good approximation to the actual root of our original equation. This number here, 4.3e-07, is known as scientific notation in Microsoft Excel. Excel uses scientific notation in order to express very large numbers or very small numbers. In this case, this number here is the same as a 4.3 times 10 to the power of minus 7. So this is the more conventional way to express a very large number or a very small number. And this is the equivalent notation in Microsoft Excel. Great. The last thing we need to do here is to apply our improved guessing and checking technique. We need to rewrite the equation just slightly to get the form that we need. So first thing I'll do is to add x to both sides of the equation. And that's it. I'll swap the left and right side. And I'll replace the x on the left-hand side with xc, and replace the x on the right-hand side with xg. We will have our predefined tolerance, also known as epsilon, and this would be 0.0001. And I'll create a table to perform our improved guessing and checking technique. This will be xg, this will be xc, this will be the error, and this will be our test. So xg, let's put an initial value of, let's say, 0.66, and xc will be cos of this value minus 0.2. Our error will be the absolute value of xg minus xc, and our test condition will be comparing the two numbers, the error and our predefined tolerance. We want to keep iterating if our error is larger than the predefined tolerance. So we will use the if statement to perform this conditional logic. I'll fix this reference, and we'll keep iterating if this condition is true, else we'll assume that is close enough. The next value of xg in the next iteration will be xc of the previous row. I can now copy these 3 cells to the next row, and we're nearly done. Okay, it took us many cycles, many iterations to get to a good value, but we've finally arrived to a good value right here. This is known as convergence, as xc and xg have converged to approximately the same value, and this will be a pretty good approximation to the actual root of our original equation. All right, thanks. Thanks for listening, and I look forward to seeing you in the next video.